Hello, myself Dr. Hafiz Ahmad, Selection Grade Lecturer, Department of Mechanical Engineering, Srimati LV Government Polytechnic, Hassan. In today's video session, I am going to give a talk on spring balance. The spring balance comes under Unit 3, Subject Mechanical Measurements, Chapter Measurement of Force, Torque and Pressure. And today's session is 23rd session on the subject Mechanical Measurements. This subject belongs to third semester Mechanical Engineering for diploma students. The contents of Unit 3 include: the first one is the force measuring devices. In the force measuring devices, we are going to discuss about spring balance, proving ring, strain gauge type load cell. Then secondly, we are going to discuss about the torque measuring devices such as pronic brake dynamometer and hydraulic dynamometer. Thirdly, we are going to discuss about the pressure measuring devices, which includes diaphragm type pressure gauge, Bourdon tube pressure gauge and McLeod gauge. There are totally 8 different devices. We are going to discuss about the construction, working and applications of all those 8 devices. From the exam point of view, the contents of Unit 3, we are having 20 marks from force measuring devices, torque measuring devices and pressure measuring devices. There will be 20 marks for the final semester exams. And the contents of today's session include the introduction to force and its applications. Secondly, we are going to discuss about the spring balance, proving ring and strain gauge load cell will be discussed in the future sessions. I welcome you all to this session on spring balance. For 2 minutes, just you watch what are all the animations coming on the screen. Just observe it. Now, if you see the animation of this football, a kid is going to, at this position, he applies a small force. The height of the ball will be very low. When the boy hits with a bigger force, the height of the ball goes to a very high. Now consider this animation. If there is no force acts on the spring will be in the rest position. Because of the application force, it will get elongates. And at this same time, you can see, due to the application of force, the length of the spring increases and its diameter decreases. And coming to this tensile test specimen, when you are going to apply a pull type of force, the length of the specimen gets increased, its diameter gets decreased. Now consider a specimen subjected to a compressive force. In this case, when a downward force or the compressive force acts, its diameter gets increased and its length gets decreased. After observing all these 4 animations, we can define force in different ways. The first definition is that suppose when we are not going to touch this ball, it is not having motion. When we are going to hit the ball, it may move forward or it may go high. Therefore, the first definition of force is that the force may be defined as an agent which tends to produce or destroy the motion. This is the first definition of force. Force is an agent which tends to produce or destroy the motion. Then now comparing if you see here, either in tensile or compressive or this stretching of a spring, in case of a tensile test, the length increases, diameter decreases. It means there is change in size and shape. Similarly, if you see this compressive test specimen, when downward force acts, its diameter increases and length decreases. It means there is change in size and shape. In case of a spring, when you are going to apply a force, here also there will be increase in length, decrease in diameter, that is change in size and shape. When you consider this animation of football, the football will be in the rest position. When you apply a force, it has motions. Therefore, the second definition of a force can be defined as force is a quantity capable of changing the size or shape or motion of an object. This is the second definition of force. Now we can define the force in the another way also. The third definition may be a force is defined as a reaction between two bodies. If you compare this tensile and compressive test, here two different types of reactions are going to occur. It means the testing specimen or the job is one body and the force which you are going to apply is the reaction. Depending upon the tensile reaction or the compressive reaction, the length, the size and shape of the job is going to get changed. Therefore, the third definition of force is defined as the reaction between two bodies, and this reaction may be in the form of a tensile force as in case of a tensile test specimen, or it may be a compressive force as in the case of compressive test specimen. Therefore, we should remember that the third definition of force is it is a reaction between the two bodies, and the reaction may be either in tensile force or the other type of reaction may be a compressive force. And generally there is another simple definitions which you have studied in class 10th. What is that definition? That is related with the Newton's second law of motion. What does this Newton's second law of motion states? It states that the force is the product of mass and acceleration, that is F is equal to ma. This is the simplest definition out of the four definitions. Still maybe more definitions may be available. Let us remember any one of these four definitions. The last one is the very simple definition. Force is defined as the product of mass and acceleration, that is F is equal to ma. And the force, if you see this sketch, it is if you want to stretch this string, we are going to apply some force. It has magnitude and also it has a direction. Since the force is having both magnitude and direction, it is a vector quantity and its unit is newtons. You should remember the force is a vector quantity and also it has unit newtons. And if you want to define the one Newton is equivalent to the force required to accelerate a mass of 1 kg at a rate of 1 meter per second square. Or simply we can write it as 1 Newton equals 1 kg into 1 meter per second square. And also we should remember that the fundamental unit of mass is given in kilogram. These are the things to be remembered in force. There are various definitions for the force, and you should know what is the unit of force and what is the fundamental unit of mass. Now, coming to the methods of force measurement, there are two methods of force measurement. One is direct method, second is indirect method. In direct method, we are going to compare an unknown force with the known standard mass. This is direct method. Example, a physical balance. If you go to the vegetable market, usually we see that a physical balance or the analytical balance, where on one side a standard mass is kept and the unknown mass or the unknown force, for example, it may be onion or it may be tomato or any other vegetables they are going to weigh, they are going to put on another pan. A standard mass is kept in one pan, that is 1 kg, 2 kg, 3 kg weights, and on the another pan they are going to put the unknown force. When the pointer reads 0 reading, at that time the physical balance is get balanced, and that unknown force will be equal to the known mass. And this direct method are compared with the primary transducers. It means this instrument in direct method they are going to give the direct reading. Then the second is the indirect method. In indirect method, we are going to make use of calibrated transducers or elastic members, which are going to sense the force. And this indirect method involves the measurement of the effect of force on a body. This indirect method involves the measurement of the effect of force on a body, and the deformation of the body due to the force applied is measured. You remember, in indirect method, the force applied causes deformation to the body. That deformation due to the force applied on a elastic member is measured. And after the deformation which is going to happen, for measuring that in terms of applied force, sometimes what we do on the elastic members such as diaphragm, we are going to mount the strain gauges. When we are going to mount the strain gauges, due to they are cemented to the elastic member. When the elastic member gets deformed, the strain gauges also get deformed, and due to the deformation of the strain gauges, there will be change in resistance of the strain gauges. Due to this variation in the change in resistance, the output voltage also going to get varied. This output voltage is calibrated in terms of the applied force. It means in the indirect method, the first reading is taken from the elastic member which gets deformed. Then secondly, to get the output from the strain gauge, secondary instrument is used. Primarily elastic member is employed, secondarily strain gauge is employed to give the value of the applied force. Therefore, this indirect method is compared with the secondary transducers. Now let us discuss about the application of force. Now the first application of the force is employed for weighing of an object. The second application of force is that for studying the behavior of material under different types of loads. Different type of loads means it may be a tensile load, or it may be a compressive load, or it may be a sudden load or impact load. Then the third application of force includes the monitoring of earthquakes or seismographic effects. And another application I can tell you that for control automation in case of opening of an airbags when accident occurs in automobile vehicles. This is also an application of force. These are some of the applications of forces. Now, Let us discuss about the different types of force measuring devices. From syllabus point of view, we are going to study the spring balance, proving ring and the strain gauge load type cell. But for our knowledge, let us know what are the different measuring instruments for weighing an object. The first one which I have shown here is the analytical balance. This analytical balance is also called as physical balance. Here it is having two equal arms, hence it is also known as equal arm balance. At the center it is fulcrum or pivoted. On one end we are going to apply the standard mass, and on the another end we are going to apply the unknown mass. This is used for weighing up to 10 kgs. For larger forces or weights, we go for platform balance, and here we are having non-equal arms. This platform balance is also known as non-equal arm balance, employed for measuring larger weights. The next is the digital platform balance. This is employed for, here the human interference in taking the readings is avoided. Direct display reading will be there. Then the next type is the piezoelectric transducer. There are certain crystalline materials are there. When they are subjected to force or stresses, they undergo deformation. Due to this deformation, it is going to produce the charges. The charges which are going to produce the voltage that is calibrated in terms of the applied force. The next type is the hydraulic load cell. Here we are going to use some type of fluid which gets deformed. Then the deformation of the fluid is made to read on the scale which is calibrated in terms of the force. And the next is pneumatic load cell. In case of a pneumatic load cell, instead of a fluid, air is used as the media. Next is the strain gauge load cell. In strain gauge load cell, on the elastic member, strain gauges are mounted, and when there is deformation in the elastic member, the strain gauges undergo deformation, the resistance changes, the change in resistance is calibrated in terms of the applied force. Then next is the vibrating wire transducer. These are some of the commonly employed instruments for weighing of an object. Now coming to the force measuring devices which are included in our syllabus, we are going to discuss about the spring balance, proving ring and strain gauge type load cell. These are the three instruments which are going to discuss for four measuring devices. In today's session, we are going to discuss only on spring balance. Now let us discuss on spring balance. Now if you see this spring balance, various designs or models can be seen here. Here in the first type you can see a platform. The object to be weighed is kept on this platform. In the second type, it is having a digital type display for giving the readings. In the third type, there is a dial indicator. The pointer moves on the dial indicator and gives the reading of applied weight or the force. Then the fourth type is the pointer moves on a graduated scale and gives the reading of force or the weight of an object. There may be still more designs may be available. And generally the spring balancers are used for the measurement of weight of an object. And in spring balance generally what happens, the basic principle is that it converts the applied force into displacement based on the spring constant. You should remember, a spring balance usually converts the applied force into displacement, and it generally works on Hooke's law. It works on Hooke's law. The definition of the Hooke's law is that the force needed to extend the spring from its rest position is proportional to the distance that the spring is extended from its rest position. This is the definition of Hooke's law. Now, I am going to simplify this Hooke's law further. According to this law, what happens if you see these three sketches? Now, the spring without the load is at rest position. It is going to give the reading here. And when I am going to apply the weight, the spring is get extended through certain length. Therefore, according to the Hooke's law definition, force needed to extend, it means we are going to apply the force here. This, when we are going to apply the force, this is going to extend, and the force needed to extend this length is proportional to the distance that is spring extended from this rest position, is called as Hooke's law. Now, to avoid this memorizing this Hooke's law, I will explain with another way. Now consider a spring, let its length be L. Now assume that some mass is suspended, and this mass which is attached to the free end of the spring will act as deforming force F. Due to this deforming force F, what happens? The spring gets extended to a length X. Because of the application of the deforming force F, the spring gets extended to a length X. It means when you are according to Hooke's law, there will be, when we are going to apply a deforming force, the length is going to get proportionately changed. For elastic deformation of a spring, the deforming force is directly proportional to the change in length. Suppose if I am going to increase the magnitude of this deforming force, suppose what happens if I am going to increase this magnitude of the force, the length also should get extended through that proportionate. Therefore, by looking into these figures, we can say that the deforming force, or if I can say that for elastic deformation of a spring, the deforming force is proportional to the change in length. This is what the Hooke's law states. I can write it as, for elastic deformation in a spring, that is, deforming force is directly proportional to the change in length. Now, if you are having confusion, I can simplify this. Now consider a spring of length L and make that spring to fixed at one end and the other end is kept free. Consider a spring of length L and the spring is attached to one end, the other end is free. Now at this free end you apply some load. I will call the deforming force as F deformation. When I am going to apply a deforming force F deformation, there will be a corresponding extension or stretching of the spring to a distance X. Therefore, according to Hooke's law, this deforming force F deformation is directly proportional to the change in length. This is what the Hooke's law states, that because of the application of the deforming force, this deforming force is directly proportional to the change in length x. Mathematically, we can write this as deforming force is directly proportional to change in length x. To remove this proportionality limit, we can write it as F deformation is equal to Kx. It means the deforming force is equal to the sum times the constant x value. And here this K is called as spring stiffness or proportionality constant. Now, or sometimes we can call this K as spring constant also. Therefore, for according to Hooke's law, the deforming force F and the displacement x is linear and is given by F is proportional to x. When this proportionality limit is removed, it is going to become F is equal to Kx, where K is a spring constant or spring stiffness or the proportionality constant. Now let us discuss about the working of spring balance. Now consider a spring which is fixed at one end and the other end carries a pan. Now the object to be weighed is placed in a pan. It may be a small force or it may be a large weight. When you are going to place the object to be weighed, the spring deflects due to the weight of the object. In working, you should remember one end of the spring is fixed and the other end carries a pan, and the object to be weighed is placed in the pan. Here you can see object is placed. When you are going to place the object, compared with this position, the spring deflects due to the weight of the object. Depending upon the weight of the object, the spring gets deflected. And the position of the needle or the pointer is made to move on the graduated scale, which is calibrated in terms of the weight of an object. The pointer is going to move on a graduated scale, which is calibrated in terms of weight of the object. This is about the spring balance. Now coming to the model questions, there may be the first question from the exam point of view. He may ask the question, define force and list any three force measuring instruments. And we have already discussed, for defining a force, various definitions I have given. The first definition is that force is an agent which produces or tends to destroy the motion. Then the second definition may be, it is a quantity which changes size, shape or motion of the body. Or the third definition of force may be, it is a reaction between two bodies, and the reaction of two types. One is tensile force or pull type, second one is the compressive or push type reactions. And the fourth definition of force is, which you have studied in the class 10, that is, according to Newton's second law of motion, force is defined as the product of mass and acceleration, and the force is a vector quantity. It has unit newtons. Out of four definitions, if you write any one definition is more than sufficient. Then in this question, he is going to ask three force measuring instruments. The three force measuring instruments we are going to discuss in this chapter are: one is spring balance, second is proving ring, and third one is the strain gauge type load cell. 2 marks are allotted for defining the force and 3 marks will be allotted for listing the 3 different force measuring instruments. Therefore, this question comes for 5 marks. Then the second question, which is asked in the previous question papers, are: explain with neat sketch spring balance. And here in spring balance, this question may be for 5 marks or it may be for 7 marks. When it is asked for 5 marks, 2 marks are allotted for sketch. You have to draw the sketch and you have to label the parts. A spring balance consists of the spring, graduated scale, pointer, weighing pan, and the object to be weighed. This carries 2 marks. Now, if you want to write briefly on spring balance, you should write down that spring balance is used to measure the weight of an object. Then secondly, you should know that it converts applied force into displacement based on the spring constant. And thirdly, you should know that since this itself indicates the applied force, it converts applied force into displacement, that indicates the Hooke's law. That spring works on Hooke's law, which states that for elastic deformation of the spring, the deforming force is directly proportional to the change in length. And for coming to the working of the spring balance, you should write: in a spring balance, one end of the spring is fixed and the other end carries a pan. The object to be weighed is placed in the pan and the spring deflects due to the weight of the object, and the pointer attached to the spring moves on the graduated scale, and the position of the needle on the graduated scale gives the weight of the object. And also, it is better to mention for a spring element the relationship between F and the displacement x is linear and is given by F is directly proportional to x. When you are going to remove this proportionality limit, it is going to become F is equal to Kx, where K is called as a spring constant or spring stiffness or proportionality constant. And this description is allotted 3 marks. For 2 marks for the sketch and 3 marks for the explanation, and totally 5 marks can be expected for this question. Explain with a neat sketch spring balance. These are the generally 2 different questions which can arise from spring balance. Now let us see what you have learned in this class. I have made some multiple choice questions, given 4 answers. Within 15 seconds, you should be capable to answer this question. Now, the first multiple choice question I am going to ask is: force is a quantity capable of changing the dash of an object. Now your time starts. Try to answer. The answer: A is size, B is shape, C is motion, D all of the above. Yes, you try to answer this question. Force is a quantity capable of changing dash. Yes, the answer has appeared. The correct answer is all of the above. Because when you are going to apply the force, what happens? In case, if you consider an example of a tensile force, when you are going to apply a pull, the length going to get elongated, the diameter reduces. It means size and shape are changed. Suppose if a football is lying on the ground, until and unless you are going to hit the ball, there is no motion. Therefore, the force is a quantity capable of changing size, shape and motion. Therefore, the correct answer is D, that is all of the above. The second question is: force can be applied for A. Answer is given. 4 answers are given. You try to answer now within 15 seconds. Your time starts now. The first answer is A, weighing of an object. B. Study of behavior of materials under different types of loads. C. Monitoring of earthquakes. D. All of the. Yes, the correct answer has appeared. The force can be applied for all those three things. Therefore, the correct answer is all of the above. Then the third question or the thing you should remember in spring balance is that spring balance is a device used to measure the. Your time starts now. Try to answer. A. Weight of an object, torque of the shaft, pressure, none of the above. If you see this torque of the shaft, it is related with the rotary motion, and spring balance never measures the pressure. None of these now above is also not there, and the spring balance. The correct answer is the spring balance is a device used to measure the weight of an object. Yes, this is the correct answer. Now let us go to the next question. That is the what you have to remember. In a spring balance, force is converted to dash based on the spring constant. 4 answers are given. Your time starts now. 15 seconds. Try to answer. A. Rotary motion. B. Oscillation. C. Displacement. D. All of the above. You try to remember here Hooke's law. What that it states? It converts applied force into displacement or the distance. That is, therefore, the correct answer is C. That is displacement. Now the next question is, force needed to extend the spring is proportional to the distance that spring is extended from its rest position. Yes, your time starts now. The answer A is given as Newton's second law, B Ohm's law, C Hooke's law, and D is torsion. This Newton's second law is concerned with the definition of force. Ohm's law is concerned with the electric. Torsion is concerned with the rotary motion. Whereas the correct for spring, for changing the deforming force is proportional to the change in length of the spring. Therefore, the correct answer is Hooke's law. Then let us discuss about the next question, or we should remember in spring balance, for a spring element, the relationship between a force and the displacement is, your time starts now for answering. A. Rotary, B. Linear, C. Transverse, D. Oscillatory. Yes, the correct answer should be, just think and think and think. The answer will be, yes, the correct answer is linear. For a spring element, the relationship between a force and the displacement is linear. The seventh thing to be remembered in spring balance is that for a spring element, the relationship between a force is dash to displacement. Your time starts now. 15 seconds. Answers are given. A. Directly proportional, B. Inversely proportional, C. Either A or B, D. None of the above. Yes, try to answer. Otherwise, the answer has already appeared. The answer is directly proportional. For a spring element, the relationship between a force is directly proportional to displacement. Therefore, answer A is the correct answer. Then the next question here is, in a spring balance, one end of the spring is fixed and the other end carries a. Your time starts now. Try to answer. A. Pointer, B. Scale, C. Pen, D. All of the above. If you are not going to answer, it will appear within 15 seconds. Time has already started. Yes, the correct answer will be, yes, already it has appeared, that is pan. In a spring balance, one end of the spring is generally fixed and the other end carries a pan. The pan is the correct answer. Now let us go to the next question. The position of the needle or pointer moved on the graduated scale gives the dash of the object. And 4 answers are given. Your time starts now. Try to answer. A. Torque, B. Distance, C. Force, D. Weight. Yes, the correct answer should be, the correct answer is D, that is weight. The position of the needle or pointer moved on the graduated scale gives the weight of the object is the correct answer. And with the last question I am going to end this session. The last question is, dash is a device used to measure compressive and tensile load. You try to answer this. The first answer is spring balance or the spring scale, B is the proving ring, C analytical scale, D all of the above. Yes, the correct answer is going to come up here. If you are not going to answer, yes, it is already, it has appeared. The correct answer is B, proving ring. And this proving ring we are going to discuss in tomorrow's session. The proving ring I have not discussed today, so that you should remember that this proving ring is a device which is used to measure either compressive or tensile load, and it will be discussed tomorrow. References: the team members for the subject mechanical measurement, I hope you have enjoyed this section. I will conclude here on spring balance. In the next section, let us start with proving ring. Thank you.